All right. Like I said, multiplication and division of fractions, word problems. That is a typo again. Whatever. You guys know what's up. Alrighty, so let's get started. So the process, this is not really that well made. Um, at the end of the day, you want to use what's up here in your head to figure out whether you need to know how to multiply or divide based on the information they give you. That being said, there is a few tips I can maybe give you. So here you go. So it's a simplified rundown of the general steps you should take when you tackle a word problem. And like I said, of course, don't always rely on this general outline. This is just the outline at the end of the day. Always be thinking on your own and use your own brain. You guys are pretty smart, so you guys can handle it. And plus, you guys know how to do this anyways. I learned this in 4th and 5th grade too, maybe 3rd grade too. All right, so step 1, read out the problem and find out what you're solving for. You want to find out which part of the problems you're going to use to solve the problem and find out how you're going to interpret the problem. There's many ways to interpret it, and usually there's only one right way. Unless it's like one of those trick problems, brain teaser thingies that you find on YouTube. That's something else, okay? Step 2, determine which numbers or fractions you're going to use to help you solve the problem. I think it's going to be all fractions today. There might be some mixed numbers. We'll see. I think there are. Yeah, there are some mixed numbers in there. Step 3, find out whether or not you need to divide or multiply. So based on what you read from the problem, what you interpret, it's important because if you do the wrong operation, you're obviously not going to get the right answer. And it might not even make sense. So that's also important. Make sure your answer makes sense. All right, step 4, you solve the problems using steps 1, 2, 3. 1, 2, 3, not well, 1, 2, 3, yeah. Fun. And then after you solve, you want to determine whether or not you require units in your answer. Usually you will, because it's a word problem. Make sure you answer the problem itself. Don't just put a number down because you didn't answer the problem or question. And you also want to see your answer is reasonable and or it makes sense. So for example, if a question asks you at the end, how long is whatever this thing is, and you get a negative answer, that wouldn't make sense, right? You can't have negative length. You can have negative distance, but negative length, nah, you can't do that. And even the negative distance is a little iffy because if the question tells you how far the thing traveled, not person, how far like a thing, a car, a person maybe travels forwards, then you somehow get a negative answer. That wouldn't make sense. And another example, if you get a large number for an answer, but you're only given small numbers, you should check to make sure if that's right. Because for the most part, small numbers will lead to small numbers and large numbers will lead to large numbers. So for the most part, that is. All right, let's get started. And oh no, never mind. Not get started. A few keywords. So look for these words when you see a problem. Personally, I don't look for these words when I grew up doing this, but this is actually pretty helpful when I thought about this. Usually when you multiply in a word problem, you're gonna have see of, multiply, times, and all. So look for these keywords, which means if you see these words in a problem, you can think, hey, maybe I should multiply. And then for dividing, if you see the words divided, split equally, cutting, and each, anything along those lines, you can generalize it. Then you probably want to divide. Oh, I'll get to that later. The asterisk of the of and each. So of and in each both usually guarantee the respective operations. That is a typo. I think I made this slide today, but because I was thinking about this, like, wait, I should tell them about keywords. So usually when you see of, usually means multiply, right? And usually when you see it in each, because you divide, because you're compartmentalizing things. I thought something equals something. That's something else, Zoe. That's something else. But this is for word problems. If you're seeing word problems, you'll see an example soon. Okay. And obviously, I'm talking fast. Obviously, remember to ask yourself, does the operation you do make sense in relation to the problem, pertains to the problem? And always check for reasonable answers. Always make sure your answer makes sense or not. All right, let's try problem 1. dot, 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 dot. Okay. A box that weighs 9 1/3 pounds contains robot kits weighing 1 6 pounds apiece. I should say pounds, whatever. How many robot kits are in the box? So I'll do this for the first few questions. What operation do you guys think you'd be doing? Mm-hmm. Mm-hmm. Yeah, should be pretty obvious, yeah. Because you have a one big total part and then you have a piece, so it's like different parts. No, well, you could try mental math in this. You could mental math this, yeah, you could. You could, yeah. Yep, yep, yep. Okay, I'm seeing a lot of divisions. Yep, so it is division. So I'll give you guys a few minutes to work out this problem. Should be really fast. And make sure you answer the question. You don't have to tell me an answer if you don't want to, because I will have the answer in the next slide. That's because I'm not talking. Don't worry. What does that mean, Fairwin? You don't have to if you don't want to. I guess you should to tell me if you're done. Yeah, sure. You can do it. Yeah. Tell me. Chat me the answer. Yeah, sure. Message me an answer. Should be really easy. Answer 31. Yeah, you're right, Aiden. What do you mean by that, Fairwin? The answer is not 31. If you remain at 6. Oh, it's not 31. No. You want to divide the total amount of pounds you have by each robot kit, how much they weigh. So it's not 31, remainder 6. Good try, though. Good try. I just sneezed. Sorry about that, if you heard it. Yep. All right, one more minute. One more minute. Nice try, Sophie. That's not the right answer. If you have a total of 9 1/3 pounds and each robot kit is 1 1/6 pounds, which one would go first? You have a total of 9 1/3 and you split them apart, 1 1/6 pounds each. Okay, I'm seeing a lot of correct answers. It's just a few stragglers.
Okay, I thought 1 1/6 was 11/6.
Sorry, yeah. Yeah, just
Not really clear.
this is if you see a space, I should be more clear, but like I said, PowerPoint doesn't like me writing mixed numbers. They don't like me writing fractions. And plus I already made these a while back. So if you see a space, noticeably see a space, then it'll be mixed number. Yeah, I'm seeing a lot of our answers. So yeah. All right, let's move on. All right, so because each robot kit weighs a certain amount and you have a total weight given to you, you want to divide So thus you divide 9 and 1/3. So you use this space right here. 9 and 1/3 by 1 and 1/6. So you convert them to improper fractions, you divide them, take the reciprocal, multiply. So reciprocal of 7/6 is 6/7, then you multiply. And if you cross reduce here, you would get 4 times 2. So yeah, it would be 8. It would be 8. So your answer is not just 8, though. There are 8 robot kits inside the box. Now you got to answer the question. Not looking at the screen. Oh, you got it right, Fairway. Good job. It's 8. Oh, 8 robot kits, rather. Okay, next one. 2/3 of Dan's class prefers chocolate to vanilla. Dan's class has 60 students in it. How many students prefer chocolate and how many students prefer vanilla? So what do you guys think you should do? What operation? This is also pretty obvious, maybe, if you see the keyword. Mm-hmm. Mm-hmm. Yeah, the answer is obvious, yeah. Don't give me the answer yet, but answered my question about what operation to do. You prefer donut? Yep. Yep, multiplying. Okay. Yeah, the answer is really obvious. 60 is an easy number to work with 2/3. So mentor is multiplying because you see the keyword of. So not everybody's given an answer yet. So you would so I'll just give a few minutes, but you would multiply because the keyword of. Yeah, it's pretty easy stuff. Pretty easy stuff. That's why I might let you guys, if we have extra time, I'll let you guys out early. Okay. Yeah, I made a lot of answers. Yeah, you guys just know it already. Okay, so because the keyword of is in the question, you multiply. So 2/3 of 60 is 40. You can cross reduce here. 20 times 2 is 40. And then 40 students in Dan's class prefer chocolate. And to find the amount of students prefer vanilla, either do 60 minus 40, which is 20, or just 60 times 1/3, which also you can reduce. It's just a 20. So 20 students in Dan's class prefer vanilla. Easy stuff, right? Easy stuff. Okay. A recipe for a certain cake calls for 3/8 cup of sugar. If a baker were to make 7 of that certain cake, how much sugar would be needed to do so? So this is also pretty easy to see. Which operation? Yeah. And the answer is really, really obvious because you can't simplify. This one, cup of sugar, not this of. In this case, it wouldn't be of. But yeah, I'll give you guys a little bit to do it. Uh, yeah, 2 and 5/8. Yeah, that works. I didn't do improper fractions. All right. So why did I copy? Whatever. So 7 times 3 over 8 is 21/8. So it takes 21/8 cups of sugar to make 7 cakes. 2 pounds, 5 cups. 2 pounds, 5 cups. Whoa, where do you get pounds? Yeah, 3 times 7. Really simple stuff because you make 7 cakes. Really simple. What if you made 1/2 of a cake? How many cups of sugar would you make? Or how would you need? That should be also painfully obvious. What if you did 1/2? So imagine this was 1/2. Yeah. Let's see. You could say that, Zoe. Have him whole numbers. Do whole numbers. Let's see. Whole numbers. If you have 1/2 of cake, if you made 1/2, you could say 1.5 over 4, but that's not it. necessarily. Not 1.5 over 4. Yeah, 1.5 over 4, but it's not it. All right, so if you made 1/2 a cake, you just multiply this out because this is notice how this is the same as dividing by 2, because that's what 1/2 means. Yeah, 3/16. It's the same thing as dividing by 2 because the reciprocal of 2 is 1/2. So this would be 3/16 if you made 1/2 of a cake. Obviously, if you made 2, it would be 3/4 of cups of sugar. So if you made 1/2, it'd be 3/16 cups of sugar. No one says that in real life, by the way. Okay, no, well, actually, bakers do, but laymen don't. They home chefs don't really do that. All right. Problem 4. This is all on your own. I'm not gonna ask you what operation we do. 4 hikers are on a hiking trip and are evenly. What is wrong with me? And evenly share out 3 1/3 quarts of energy drink among themselves. How much drink did each hiker receive? Can you make bread with ice cream, Milton? Well, first of all, that's not on topic. Second of all, maybe? I don't think so. Maybe if you add the ice cream after you make the bread, then obviously. Yeah, you shouldn't be able to, because then when you bake the dough, your ice cream just melts. So if you add the ice cream after, then maybe. But that's disgusting. I'm not gonna lie, that sounds bad to me. All right. Tell me the answers when you guys are done. I will do this problem with you guys. Let me just cross this out. Keep it in fractional form. Yeah, keep it fractional form. Dang, Andrew, I see you. I see you. Took all the drink. Yeah, yeah. I think I typed the answer wrong. We'll see. I think I did. Do they have to drink all of it? Yeah, assume they like split all of it. No, well, they don't have to drink it. Just how much drink did each hiker receive? It doesn't mean they drank any of it. They just got it, received it. 13 1/3. That's not right, Zoe. Try it again. Let's try that. I think I typed the answer wrong, but I'm getting a lot what you guys are getting. So hopefully I didn't type the answer wrong. I was in a rush when I made this one. I'll give you that. Okay, I'm getting a few more answers. No decimals, Zoe. So keep it whole numbers. So just multiply that by 2/2. And you should get your answer. Yeah, you get your answer. Yep, there you go. Okay, getting a few more answers. Yep. All right. But not that. What do you mean not that? Oh, I see. Yeah, that's not it, Megan. Yeah, there you go. Okay, let's move on. I think I wrote the answer wrong, but we should got 5/6. Yeah, 5/6 quarts. Hopefully I didn't write the answer wrong. Oh, I didn't. Oh, amazing. Okay. So hikers are trying to split something up equally, so you divide the 3 1/3 quarts. That should be an S. What is wrong with it? I'm telling you, I was in trust about a rush. Blah blah blah. Quartz is a mineral. This quartz with a Z, it's a beautiful looking crystalline mineral that forms lattices when chemically combines with carbonic air. Anyways, so you divide the total amount of energy drink you have by 4 because there's 4 hikers. So do 3 1/3 divided by 4, which is 10/3 times 1/4, because reciprocal of 4 is 1/4, and you multiply. So it's 5, 6, because you can reduce this. 5 to 2. 3 times 2 is 6. 5 times 1 is 5. All right. So each hiker receives 5, 6 quarts of energy drink. Energy drink. Do you guys even like energy drink? What's your favorite? Mine personally is Powerade. No, Gatorade. I like Gatorade more than Powerade. Do you guys even drink energy drinks these days? I don't think so. Gatorade? Yeah. Don't know. Yeah. You have tennis? Of course you do. You're Asian. I'm joking. I'm joking. Use. Don't drink energy drink. Yeah, honestly, water is the best, obviously, but once in a while, if you really need the boost, energy drinks are the way to go. Okay. All right. Problem 5 out of 9. We're almost done. Do you like milk? Coke? Coke is not good, obviously, for energy, yeah, but then obviously sugar, lots of sugar, and caffeine. Coke has caffeine in it too, so be careful. You like milk? You guys like milk? Okay, I see. Milk is good too. You like red tea with milk? Oh, okay. Tea also has a little bit of caffeine. Jenny, you don't have to tell me which operation. Okay, that's besides the point. Anyways, next problem. Matt is building a treehouse and he needs 24 boards for one wall. Each board is 3.5 feet long. This is 3.5. What is the total length of the boards needed for the wall? So for one wall. And what is the total length of the boards needed for 4 walls of the treehouse? I did 3 and 1/3 of the Yeah,
So each board is 3 plus half feet long, right?
3 and 1/2. Yes, this is a mixed number. It's a mixed number. 3 and 1/2 feet
Okay.
long. Patience. And
Yeah, my microphone is working.
make sure you. I can't talk today. Make sure you use the right units. Make sure you use the right units. Yeah. For one wall, yeah. As long as the treehouse will be yours, he needs that many feet of boards. Okay, Andrew. You greedy, man. I'm joking. Alpha. That's pretty alpha right there. Okay. I only see a few answers, but so far they're right. You want the treehouse though? Um, let's see. 24. Jingwen, each board is 3.5 feet long, not 4. 3.5. It's a mixed number. But you have the right idea. Yep. Getting a lot of good answers. That's right. Yep, Sophie. Yep, Zoe. Yep, Megan. Yep, Jenny. If the tree house is not mine, you only need 1,000 plus feet of boards because you'll be making a house for the tree. Wait. That is an XD moment right there. XD, dude. Yeah, that's true, Ryan. That is true. And then answer the second question. Make the treehouse out of cheese. That's disgusting. I'm not gonna lie, Aiden. That's disgusting. Maybe an A. An A, Jenny. Grammar. An A. Because your next thingy is a vowel. An A. Makes the treehouse out of cheese. So
Yeah.
that's pretty disgusting, Aiden. That's All right, let's see. I don't think everyone's done yet. I've never had a math teacher that cared about grammar. Oh, well. Well, I'm not really a teacher. I'm just a high school graduate, but I do find grammar important. Yep, that's right, boy. Yep. We'll make it my favorite cheese. What is my favorite cheese? Cheddar? Probably cheddar. Yep. All right, you guys seem to be done. So let's go. All right, so it's multiplication because you are duplicating the length of the boards 24 times because you have 24 boards and each board is 3.5 feet long. Yep. 420 feet for 4 walls. Check your multiplication, Joseph. Check it. Yeah, 84 times 4. Yeah. Okay, so you had 24 times 3.5 feet, which is equal to 24 times 7 over 2. You can cross reduce this. 12. That's a bad 2. So 12. This is 1. 12 times 7 is 84. So 84 feet. So for 1 wall, total length needed is 84 feet of wooden planks or whatever. You don't have to say that. So for 4 walls, the total length needed is 84 times 4 walls, which is 336 feet. Also, the leaves of the treehouse have to have each and every individual mansion. And each and every... Okay. Moving on in. Tree, not treehouse. Oh, okay, yeah. Okay. All right, moving on. Problem 6. This one should be simple too. Cecily works at a swimming pool as a lifeguard. The pool is open for 7.5 hours a day. If each shift is 1.5 hours, so these are mixed numbers, so 7, 1.5, 1.5 hours long each. So each shift is 1.5 hours long each. How many shifts are there at the pool per day? Yes, thank you, Jenny. That is right. You do division. Yes. Should be painfully obvious that you do division because there's a big hours of operation. Then you slice it up in different shifts. Nice try, Zoe, but don't think that's the right answer. Yeah, that's not the right answer, yeah. I'm not gonna answer that for you, Boya. You figure it out yourself. you gotta figure it out. Figure it out yourself. Yes, you're right. 5 shifts. Yes, that's right. Yeah, there are 5 shifts per day. As long as the swimming pool is also, it's not mine. There'd be 100 shifts. It's not 3, Jenny. Nice try though, with your little A. Nice try. Andrew, that's just cruel, Andrew. That's messed up, man. Yeah, good job, Ryan. Yeah. That's just messed up. If it's not yours, 100 shifts. That's just no. That's close, Zoe. Close. That's not the right answer though. Are you sure you're dividing the right order? Because if the hours of operation, the total is 7.5 hours, and each shift is 1.5 hours. Catherine, that is not right. What did you do? You got 50 over 6. Let me see. 50. Are you sure you're dividing? Yeah, there you go, Jenny. That's right. Yeah, that's right, Boya. That's right, Julie. The swimming pool is yours now, Andrew. Guys, you guys hear that? Does everybody consent to that? Is the swimming pool Andrew's? Do you guys agree? Yay or nay? Yes or no? Oh, Jenny says no. Okay. You divided 7.5. Check your math then, Zoe. Nay. No. Andrew, the saying no. Yeah, that's right, Scarlett. That's right. I'm waiting for a few more answers, but I think everyone's got it. If the swimming pool is not mine, I will destroy it with my wrecking ball game. That's supposed to be. Are you sure? Okay. Okay, so you guys should have got 5 shifts. There's 5 shifts at the pool. So you divide how long the pool is open for by the length of time, the length of each shift to determine how many shifts there are. Who's Cecily? Cecily. I had a classmate named Cecily. had. I think she moved out like a week after. Okay, so you do 7.5 divided by 1.5 equals 5. I guess I'll do the math out for you guys. See, that's 15 halves times 2/3. These go away, so you get 15 over 3. I'm not going to do that because it's more obvious this way. So it's 5 shifts. 5 shifts. So it's 5 shifts at the pool per day. Oh, you added, Zoe? The lesson is not even about. It's multiplying and dividing. You added divided too? Oh my god. Okay. So yeah, now you know. 7.5 divided by 1.5. Not cat. Okay, 30 over 6. Well, you know how to do it now, Catherine. So I hope you see it. Double try. Alrighty. 6. Okay, this one's not even that hard. Maybe you guys might not get it. You guys might be stuck. Okay. Amelia runs twice as fast as Mike. If Mike can run 5/8, 5/8 of a mile in 9 minutes, how far can Amelia run in 5 minutes? And a hint is to make a proportion to help you figure this out. You guys may or may not be stumped. Most likely not be stumped because you guys are pretty smart. But we'll see. Yeah, you can multiply. Multiplying is part of it, yeah. That's not the right unit, Zoe. How I mean, sorry, yeah, that's the right units. I mean, sorry, that's not the right answer. This is a little tough. It's a little tough. I'll tell you guys how to do it, or how I did it, how I would do it. But yeah, my hint is make a proportion. Yep, that is right. Yeah. Oh, you could do that too, huh? I'm just keeping up with the guidelines about teaching you guys proportions and stuff. But you could do that. You could do that. That makes more sense. You do that. Ow. Ow. That is not right, Andrew. And as long as you win the race, yes, you can win the race, but you did not get the right answer. Let's try though. Yes, that's right, Catherine. Oof you, yes. RIP, RIP. I don't remember if it was that. Yes, that's true, Zoe. You're on the right track. You're on the right track. Julie. That's not the right answer, Julie, unfortunately. Nice. No, Derek. No. Good job, Joseph. Nice try though. It's a little tough. It's a little tough. I'll give you guys a few minutes to do it. Yep, that's right, Jenny. You don't have to make a proportion, by the way, in this problem. I just did it to help reinforce idea of proportions, but you don't have to solve this one. You don't know how to do it? Okay, I'll tell you the answer. No, Andrew, that's, wait. Oh, that is right. You just gotta simplify that. That's right, yeah. Just gotta simplify it. Yep. And it's not per minute, it's in 5 minutes. Right. You run 1.5 of a mile per minute? But why though? But why? All right, I'll give you guys a couple more minutes. When does the class end? It should end around 6. We're almost done. Plus the speed of you walking. So you just contradict yourself, Andrew, though. Because you said you run that much. So when you walk You don't get any, when you run, you don't go any faster then? Because if you walk that pace, then you run that pace, the same thing. So it's like, replace the run with walk. Ah, okay. Okay, let's see. So you don't have to do a proportion for this one. I'll put the answer soon. Type message here. Yes, type message here. Okay, so go. So Amelia can run twice as fast as Mike. That means she can run 5/4 miles in 9 minutes. You cross reduce this. And then, so yeah, like I said, 5/4 miles in 9 minutes. You don't have to make a portion like I said, but if I walk in, I have to turn on snail mode. Feel cool. Good for you. So use that create portion while miles is on the numerator and minutes is the denominator. So 5/4 miles over 9 minutes is equal to x miles over 5 minutes. And then you solve for x. So how you solve for x? You cross multiply, then divide by 9. So if I did that times 5, 25 over 4 times 1/9, which is 25 over 36. How? Yeah. So that was my hint. You don't have to make a proportion. You could just do 5/4 times 5/9, which also works. And so, answering the question, you can't read my handwriting. Well, I'm sorry about that. You're just gonna have to deal with it. I'm joking. I'm joking here. I'll make it better. I like to write fast. Okay. So 5/4 times 5 is 25 over 4. Then you divide by 9 because you divide by the third number, times 1/9. You can't cross reduce this, cross simplify, same thing. So it's 25 over 36. Man, writing it with the mouse is hard, man. Better. Thank you, Jenny. Just like, thank you. I met your expectations. Thank you. All right, second to last problem. Bailey's restaurant bought 6 1/3 pounds of onions. So this is 6 1/3. This is really easy. The restaurant bought 8 times as much potatoes. That should be many potatoes as onions. How many pounds of potatoes did the restaurant buy? Or did Bailey buy rather? But hey. No, you did 5 over 4 times 5 over 9, Jungwon. Which you could also do. Oh, I see what you mean. Never mind. Yeah, I know what you mean. Yeah. Whatever. Now you're being very pedantic. Do you know what that means? Ah, I'm joking. Now you're being really nitpicky. I don't know if you even know what that means. You're being really, really specific about your details. Yes, that's true. That is not what I wrote back there was not right. Yep. You can keep it improper. You can do a mixed number. I don't care. I did a mixed number in my answer, but I mean, sorry, improper fraction, my answer, but same thing. Let's see. I'm getting a lot of different answers. Yeah. Really weird. There's not 152 oh, shoot. There's not that many potatoes. There's that many pounds of potatoes. And yeah, that's right. Yeah, that's right. Yeah. As long as you eat the potatoes roasted and cooked to perfection and Bailey has to pay you. You have the right number, Andrew, but not the right units, obviously, but what? What? There you go. Yep. Aiden, you are off by 8. and the fraction is wrong. Your mind is scrambled. Don't worry about it. It's fine. It's fine. It's fine. All right. This one should be easy enough. So the question literally tells you 8 times as much. So you know to multiply by 8. So you take the weight of the onions, because the question said 8 times as many potatoes and onions. So you take the weight of onions. Sorry, I'm drinking water while I'm doing this. And you multiply that by 8. So convert this in improper fraction. 19 over 3 times 8. 152 over 3. What is the unit? Pounds of potatoes. So you could also do turn this into a mixed number. 0, and it's remainder 2. Because 30 times 50, sorry. So it's 5. 50 times 3 is 150, so remainder 2. You could put decimals, I guess. Yeah, could. You got 5.060606. No, that's not right. How'd you get that? Oh my god. Yeah, I think you're right, Cindy. Let me check. Oh, you're off by. All right, you're off by 2, and your fraction. Well, let's see. No, you're right. Yeah, you're right. You just had an improper fraction in your mixed number. You had 48 over 8/3. That's a bad 8. Over 8/3. This can be you could put 2 more here because the 8 over 3. Because there's remainder. Because if you divide this in 6, 2, that's a 2. Remainder 2. So this would be 50 and 2/3. Yeah, 50 and 2/3 pounds of potatoes. So it's either this number or this number. All right, last problem, and you guys are free to go with 10 minutes to spare, so we'll see. A cookie factory uses 1.5 bags. I'll write this out. 1.5 bags of flour in each batch of cookies. The factory used 4.5 bags. 4.5 bags of flour yesterday. How many batches of cookies did the factory make? Should be fairly simple. That is not right, Jenny. That's not the right operation. There you go. Is decimal right? No, it's I'm sorry to say it's not. I think you need to move that decimal place 1 over and yeah, and redivide because the decimal is on your right. That is not right, Jingwen. Use the wrong operation. Good try though. Good try. Good try. Yep. Yep, Aiden. Yep, Catherine. Nice try, Jenny. Not the right answer. You're close though. You're close. They made that many batches of cookies and gave them all to you. Oh, 3. Okay, typo. Yeah, good. Yep, that's right. That's right, Julie. That is right, Andrew. You got the right answer. Dang, they made 0 batches. That's right, Ryan. Good job. Because you ate them. That is true, Max. Yep. You got the wrong number again, Jay. Are you going to do that? Oh, wait, hold on. Yeah, that's right, Jingwen. Yep. But you sued the cookie factory because the cookies weren't strawberry flavored. Excuse me. Oh. And you spelled flavored with the British spelling. Wow. That's pretty cool, actually. That's pretty cool. Yeah, so in the US, we spelled flavored FLAVORED. We don't add the U. That's for That's usually like UK and international English. What's the British? You add, so like, if you had the word favorite, so how we spell favorite in the US is like this, right? But in internationally, yeah, I don't know about the gray part, the gray rule, Andrew, something. Yeah, internationally, you spell favorite with the extra thingy, the U. This comes from the UK. This is the British spelling, traditionally. Yeah, that's right. Yeah. So, yeah, that's you spell favorite correctly, but not flavor. I mean, yeah. Color is yeah. So this is color in the US. This is color internationally / UK. Americans are weird, man. I'm an American too, so I will admit that Americans are weird. Yeah. That's how you spell it in outside of the US, Jenny. Yeah, in Canada, if you were in Canada, you would spell color this and favorite this. If you're in Canada, but if you're the US, you spell it the top way. No, not for table. I don't know the rule exactly, but I think it's usually the OR. But then you don't spell or like that. You just spell or like that, like and or, that kind of thing. All right. See, I got a lot of right answers. Yeah. Okay. So you divide the total bags of flour used, which is 4.5 pounds, by the amount of flour required by each batch. See, flour is spelled like that though. Like flour is, that's normal. This is thingy. American and UK. No, you don't spell, yeah, like I said, you don't spell it or. Then in the UK, oh no, you don't. You don't spell chlorine like that. Yeah, you don't spell the CHO or CHLOURINE. You don't spell it like that in the UK. They pronounce aluminium in the UK, by the way. Okay, so you have 4.5 pounds. Yep. Divided by 1.5. Because we must use the British word, but change some letters in our words because we was the overseas territory. Oh, I'm guessing you're from Hong Kong? What? Aluminium? Yeah. Aluminium, yes. They pronounce aluminium. Aluminium. And they pronounce laboratory. They pronounce it laboratory. A laboratory. Yep. Okay. Yeah. Okay, so you have 4.5 pounds divided by 1.5 pounds. So you convert these to improper fractions. And improper fraction of this is 3/2. So you take the reciprocal of 3/2, which is 2/3, and you can cross reduce to get 3. So factory makes 3 batches of cookies. And that is all for today. So you guys are free to go if you guys want. Unless you want, if you have any questions, you can stick by. But yeah, you guys are free to go. 7 minutes to spare. All 3 batches of cookies for you.
Thank you.
Bye. Yep.
Bye.
Wait, how come you can make them tall in there? I don't know actually. PowerPoint is weird. Bye guys. Like I said, if you have any questions, stick by. Yeah, I don't know, Jenny. I really don't. Did that cookie factory get sued?
Bye.
Bye guys. Bye guys. And you guys are a great bunch. You guys are amazing. Probably. Yeah, probably they did. They probably did. Yeah. Most likely. Alrighty. I'm gonna guess you don't have any questions. How did you get the 50 point? Okay, so let's see. Right. Okay. So you want this as a decimal. You just simply divide it. Take this, just simply divide it. So this would be 5. This would be 0, right? You add the 0 over here. This would be 6. 18. That's it. So it'd be 6 repeating. So you were close. You just had the zeros. You didn't have to put the 0. Yeah, you see it because this is 20. And then if I do 6 again, 6 times 3 is 18. And add another 2 to the bottom. And you just keep repeating over and over and over and over again. So, yep. So, yeah, you would have 50.6 repeating pounds LBS. That's an L. LBS of potatoes. Which in real life, you obviously wouldn't say that. You probably round it up to 50.67 pounds of potatoes, which then you just round to 51 pounds of potatoes, or even 50 pounds of potatoes. So yeah, any other questions? You guys are free to go. Yeah, leave the call whenever you like. Otherwise, I will end it. Stop sharing. All right, if no questions, I will end the call. I will see you guys next week. You guys have been amazing. Bye, guys.